In this lesson we're going to talk a little bit about, believe it or not, just addition and multiplication. And that seems elementary at this point, but it's actually important. We're going to look at it in a different way than you're probably used to. We're going to kind of look at the geometry of adding numbers, and it will help you understand later on the operations and meanings of multiplying and adding complex numbers, which is where we're going with this. So just bear with me, and I think that you'll end up understanding complex numbers a lot more than usual. So let's start with a simple example here. Let's say you were starting at we're starting at 0 on the number line, and we want to add 3. So we all know that 0 plus 3 is 3, but let's do this in terms of vectors. So we're at 0, and we are going to move to 3 on the number line. So there's my vector. So now I'm at 3. What is the length of this vector? Well, we of course know it's 3, right? 0 plus 3 equals 3. Hopefully you've stayed with me so far. Let's say in part B we want to add 2. We want to add 2 to 3. So we're going to do that, and we'll do it geometrically. So what is we'll note what is the length of the new vector? So we were at 0, we went over to 3, and now we are going to add 2. So there's my vector of length 2, and so clearly we know I'm at 5, right? And of course, no surprise, that's because 3 plus 2 is equal to 5. So the answer to this question is 5. So here's actually the big question that we're going to ask. How could I get to negative 5 on the number line at this point? So how can I get how can we get to negative 5 on the number line now that we're at 5? So here we are at 5. So we're over here at 5. Let's say this is vector 5. Vector of length 5. How do we get to negative 5? Well, there's a few ways you could do it. You could subtract 10, right? That's one thing you could do. But there's another thing you could do, and that's what I'm going to focus on, and that is multiplying by negative 1, right? So if you multiply by negative 1, of course we know that the result is negative 1 times 5 equals negative 5. So if we think about this in terms of vectors, geometrically what we've done with this vector here is we've moved it or rotated it so that now it's facing in the complete opposite direction . In the complete opposite direction, right? We times by negative 1. And now it's facing in the complete opposite direction, but notice it has the same length, right? So it has the same length. Has the same length, but it was rotated 180 degrees. Now, as a final thought, let's ask this question. How could we get back to 5 now that we're at negative 5? Well, we would just multiply by negative 1 again, of course. So if we follow this whole path, then we started at 5, we multiplied by negative 1 to bring us to negative 5, and then we multiply by negative 1 again, and that just gives you another justification as to why 5 times negative 1 times negative 1 is equal to 5, or really, negative 1 times negative 1 is equal to 5, right? Because this negative 1 rotated you 180 degrees without changing the length, but then multiplying by negative 1 again, rotated again in 180 degrees, and we were back to where we started. So you really want to associate, geometrically, multiplication by negative 1 rotates 180 degrees. Okay? Let's talk about multiplication more. If we do 2 times 3, we can view this as a vector of length 2. So let's say that's our vector of length 2. And multiplying it by 3, we know that means to basically add 2 3 times. Right? Or another way to view it is that we're scaling it 3 times. So scaling our vector 3 times. And where do we end? We know we end with a vector of 6. So here's our vector 2, and by multiplying it by 3, essentially what we're saying is we're just going to go out to 3 times in a row. Make that a 4. Okay. So let's keep going. Let's do another example. What about, what if we want to multiply negative 2? Negative 2 times 3. How can we view this? Well, I want to rewrite it because I'm going to really emphasize the geometry here in the vector operations. We're going to rewrite this as negative 1 times 2 times 3. Because in doing so, we've already known from the problem above that this is 6. We can see once again, as in the last page, that here we are at 6. And by multiplying this negative 1, that results in our vector of negative 6, which is the same length, but in the opposite direction. And so we see once again that geometrically multiplying by negative 1 rotates 180 degrees. Right? Rotates 180 degrees. Right? And that this vector has same length as our original. As a final example, I'm going to we're not going to do the geometry, but think about negative 2 times negative 3. Right? We know that equals 6, but now you can understand that it equals 6 because you can view it as negative 1 times 2 times negative 1 times 3, and you can commute these, and write this as -1 times -1 times 2 times 3, where this is going to rotate 180 degrees, but then this is going to do that too. So you're back where you started, and then we basically have our vector of length 6, bringing us to 6. So you may think that there's nothing profound going on here because I just spent almost 10 minutes talking about basic multiplication. But the key thing, this will help your understanding later, the key thing you want to remember, and we'll jot it down up here, is that multiplying by -1 has the effect on the number line of rotating rotates our number vectors, we'll call them, 180 degrees. Okay, keep that in mind and it'll help you later on.